and we are going to now move on to talking about the reliability and validity lab quiz. So in order to complete the lab quiz, here's what you need. For this and every other lab quiz, there will be at a minimum 2 files that you need in order to work on the quiz. You need this file that'll be called lab quiz whatever. In this case, it's lab quiz 2, which is covering reliability and validity. And you'll need the data set that I created to go along with the quiz. Okay, so again, when you open that file, again, you need SPSS to be working and you need the VPN to be working if you're off campus. But if it is, you should be able to open that file. You may need to save it to download it. But once you do have it downloaded, you should just be able to open this file and see all of my already pre-created data. So first, let's walk through the instructions to sort of orient ourselves to what we have going on. So the instructions will be similar lab quiz to lab quiz. The specific prompts and the specific questions will be different, but the instructions will generally read like this. Read the following prompt, open the SPSS data file provided, Josh Stacey depression data. Again, there'll be a different data set for each lab quiz. Then proceed with the directed analyses and answer the following questions. Provide your answers in a separate document. So you can just download this document and type your answers in here, or you can open a new Word document and type your answers up from scratch, but you will need to submit a file that contains the answers to the questions. In your answers document, please put answers to all the questions, even ones that have numerical answers that are included in your output. I'll describe what this looks like in a second when we get to a question that this applies to. The only exception to this is the graphs created with Chart Builder. That will also apply today, and again, I'll point that out when we get there. You don't need to copy and paste those into your answers. You can though. You can either screenshot them or just like right click and copy them, but you don't have to. Those graphs do not have to be in your answers as long as they're in your output. When you're done with your analyses, save any output into a single file. Again, I'm going to point this out when I get to it, but whenever you run any analysis in SPSS, it opens up a pop-up window labeled output. Any analysis you run will be in the same output window, assuming you don't close the output window. So do not close the output window or save the output window after every analysis. If you have a running series of analyses, just keep that same output window open, and then everything you do will be in that single file. Okay, when you're done, upload your answers and output into their separate Canvas submission portals. You might have noticed the submissions on Canvas. There's 5 points for your answers, 5 points for your output. Again, your output will naturally be created when you run the analyses, so you don't need to do like extra work for this beyond just making sure to remember to save it and upload that separately. I say late quizzes will not be accepted. Honestly, if you're having a problem, just let me know. That's not the hill I'm dying on this semester. All right, any questions so far? Okay, so now let's move on to the particulars of this lab quiz. So anyone who got a chance to look at the materials for the reliability lecture, I mentioned interrater reliability, and I mentioned an example of this that I had done in a research project that I did back in grad school, where I had coders read a series of narratives that my participants had written on different sorts of experiences. I was having the coders read the narratives to ensure that the participants were writing about the themes that they had been directed to. So this is what inspired me to create a quiz around this idea of interrater reliability and a few different ways to run analyses on this topic. So the prompt reads, Josh and Stacey are 2 trained research assistant coders. The task they have been given is one involving quote unquote content analysis. Content analysis is when you take qualitative data like narratives written by research participants and code it for certain content. You can do this using content analysis software, or you can have trained coders read the narratives and make their own judgments. In this particular project, Josh and Stacey are reading the narratives of people who have been diagnosed with depression, as well as people who have not been diagnosed with depression. They have both been given a list of assessments that they will have to make about every narrative they read. Basically, this is a list of questions they have to answer for each narrative. The questions are as follows, right? They rate the anxiety present in the narrative, the sadness, and the loneliness. They're coding for themes of depression. Once averaged together, these three items are meant to assess how much depression the narrative writer demonstrates. Both Josh and Stacy read the same 20 narratives from participants and answered those three questions. What you have to do now is figure out whether you can use the coding data Josh and Stacy provided you. Use the data set provided and answer the following questions. So this data set is going to give you the opportunity to look at reliability and validity from a couple different angles. You're going to want to have internal consistency within Josh's answers. Like you want Josh's answers to jibe together. You want to make sure that he's sort of being coherent. Same thing with Stacy. So we're going to get to run an internal reliability for them separately. And then we're going to run an interrater reliability between them. Once we've cleared those bars of ensuring internal reliability in the separate scores and interrater reliability between them, we get a good sense that we had some good, solid, consistent observations. Before we get into the analyses, given that this is our first experience with SPSS, I want to call to your attention the way that SPSS files actually look. So I'm going to walk you through a few different things to keep an eye on in your SPSS data set. So I'm going to show you variable view versus data view. I'm going to show you a few of the drop-down menus, and then eventually we're going to look at the output that appears. Oh, thanks. Okay. So this here is our data set. I mentioned this data view, variable view distinction. Those are these buttons down here. If you click on variable view, this is when you name and label your variables. So I have a variable for Josh 1, Josh 2, Josh 3, and those are the answers to his three separate questions. Likewise, Stacy provided the three questions. I have a Josh average, Stacy average, and then I average Josh and Stacy's score together to get an overall index of the depression score for each narrative. So these are just the names and labels for the variables. One thing to notice is that you can futz around with some settings on the variables themselves. You shouldn't need to do a ton of this. And I've already created all the options for the lab quizzes, but some things to notice is, for example, values. This is going to let you code categorical variables. So for example, I mentioned that the participants were coded into depressed versus non-depressed participants. If you remember the variables lecture, that's a categorical variable. It just puts people into one versus another group. So this is how you create the actual numerical labels for your categorical variable. This lets me run certain analyses in SPSS by assigning numerical categories. SPSS can't really do any analyses on words. Everything needs to be in numbers. So this is why you want to assign numerical categories to your categorical variables in SPSS. You just do that by creating labels here. That's your basic variable view. Data view is where you actually see all of the data. You see all of the actual numbers for all of those variables. Right? So you have for participant 1, Josh gave you his 3 responses, Stacy gave you hers. You get Josh's average for participant 1 and Stacy's average for participant 1, and the overall depression score for participant 1, so on and so forth for all of the participants. Okay, so that's your basic variable view to data view. In terms of actually interacting with your data and running analyses, there's 2 options. One is to use this drop-down menu. It's called the graphical user interface, or the GUI. You can basically do anything you want to do here in the GUI, and we're going to use the graphical user interface for most of our lab quizzes. We will be using a different function later on in the semester called syntax, where we can actually write a little bit of code to tell SPSS what we want to do so that we don't have to look through all the drop-down menus. We're not there yet. We're just going to use these drop-down menus. So some basic things to look for, right? File is where you can save your data. Beyond your basic file functions, there's going to be some other things we do later in the semester, like transforming our data. But for now, and for most lab quizzes, we're really either going to be living in this analyze drop-down menu or this graphs drop-down menu. This is where we basically run all of our analyses. Any questions so far? Doing good? All right. Let me look at the chat. It's not letting me look at the chat for some reason. So if anyone has a pressing question, could you just turn your mic on and let me know? Oh, man. All right, well, once I stop sharing my screen, if there are any questions in the chat, I'll be able to get to them there. But for now, I think I'm gonna move on to showing you how you can actually run some of these analyses. Okay. So how do you actually run reliability in SPSS? You're going to use what's called the scale function under analyze to assess reliability. This is going to work for internal reliability and it's going to work for inter-rater reliability. So first we want the internal reliability for the Josh depression score and the Stacy depression score. And we're going to compute their Cronbach's alpha. So we're going to need a Josh internal Cronbach's alpha and a Stacy. Let me show you how to do that. Analyze, scale, reliability analysis. Okay. Now, this is important. What actually goes into here? The actual way that you calculate reliability is going to be by putting the items that constitute the average into this right-hand box. So if I want to analyze the internal reliability for Josh's scores, just those three values will go in here. This is going to tell me the internal consistency of this value here. Think about why I don't want this in the internal reliability analysis for Josh depression. This is just the average of these three scores. What doing a reliability analysis on these three items does is tell me whether or not these three items are internally coherent, such that I can really trust this average here to give me a real good, accurate sense of what Josh thought about the narratives. So do not put the average together with the items that went into the average. So for Josh's internal reliability, just put Josh anxiety, Josh Chad, and Josh lonely. Josh 1, 2, 3. Click OK. Here's your output. Again, this is the output window that will naturally pop up for any analysis that you do. It's a separate window from your data set. Make sure not to close this. If you ever accidentally screw up an analysis and you want to get rid of it, you can just click over here and you can, maybe you can hit delete. I think on PC you can hit delete, but not on Mac. On Mac, you might have to go like Command X. I'm not quite sure. You can get rid of things that you don't want. You would never lose credit for having extra analyses in here that you didn't need, as long as you have the ones that you do need. Okay, so this is your internal reliability Cronbach's alpha for Josh's scores. That alpha is 0.928. Again, if you covered any of the materials I posted for reliability, what do you guys think about that value? Do you think that sounds high enough for reaching the bar of internal reliability? Yes. Yeah, that's crazy high, right? A alpha of 0.928, that is well within the necessary range to say that Josh's answers were coherent and consistent. We have met the bar for internal reliability for Josh's scores. It's a good thing. Okay. So I mentioned when I was talking about the instructions that you're going to need to write up in your answers the numerical values that you get, even if they're in your output. This is an example of what I'm talking about. When you go to your answers document, you need to write up an answer for this question. So assess the internal reliability of Josh depressed and Stacy depressed by computing a Cronbach's alpha. You need to tell me that Josh's alpha was this value, and you need to tell me how you interpret that result. Okay, I'll show you real quick how you could do the same thing for Stacy. Get rid of the Josh values. We don't need that for Stacy's internal reliability. For that, you're going to need the three Stacy scores. Again, do not put that in there. That does not make sense for assessing the internal reliability of Stacy's values. So once you have these, once again, you hit OK, and now here's Stacy's internal reliability. Again, look at this value and come to your own conclusion about whether or not you think that is sufficient to clear the bar for internal reliability for Stacy. Does anyone have any questions yet? Again, I don't know. Oh, I see the chat. Chaos. All right, so far so good? Okay, so that's question 2. Let's make a chart. Party. Oh, chat. How do we know it's reliable? So we use kind of rough cutoffs for what we would consider appropriate reliability in the field, just basically sort of on a status quo. If your internal reliability is above like 0.8, we like that. When it gets lower than that, like if it's somewhere in between like 0.6 to just under 0.8, you're sort of like, that's a little low, depending. Maybe there's a question that doesn't belong there, that's inconsistent. Those values clearly met the bar for what we would consider, just based on the status quo in the field, as being an appropriate level of reliability. So the answer is yes. Their internal consistency appears to be there. We like that. All right, so using a chart builder function available under graphs, create a simple scatter plot with best fit line, plotting Josh depressed against Stacy depressed. What does the scatter plot best fit line look like? So this is meant to cover the part of the reliability and validity and general variables and constructs and claims lecture where I talked about using scatter plots as a tool to visually inspect the strength of the covariance between variables that you want to be associated with one another. So basically, we want to evaluate the interrater reliability of Josh and Stacy's scores. So now that we know that Josh's depression scores are internally consistent, we feel good about just using his average depression score, likewise with Stacy. Now, we want to make sure that Josh and Stacy are living in the same universe and they're consistent with each other. So the ways to do that would be to make a scatter plot where we plot their scores against one another, which we visually inspect, and then to compute the Cronbach's alpha or interrater reliability. So first up, let's make that scatter plot, because that's fun. Graphs, chart builder. Just click OK to that dialog box. Okay. Here you get to choose what graph you want to use and the variables that will apply to that graphic. When I mentioned that for some devices, you might not be able to use the most recent version of SPSS, here's where you might see some slight differences. For example, I believe SPSS 25, you can't do a scatter plot with best fit line. That's okay. If you're not seeing this here and you're just seeing something that looks like that, just click that, that's fine. This though is that scatter plot with best fit line that I mentioned. This is going to create the scatter plot, and it's also going to draw that line that goes through the middle of the dots that lets you get a better sense of how your variables are related. So you want to click the graphic that you want and drag it into the gallery. Now you want to drag the variables that you want onto the Y and X axis. It doesn't matter if you put Stacy here and Josh here or vice versa. Doesn't matter at all. You could flip them and you would be able to basically see the same thing. Okay, so I'm putting Josh there and I'm putting Stacy there. This is not my actual graphic. Okay, you actually need to click OK. This is just a preview. So if you're thinking, what the hell, their score should not be negatively associated, this is not the actual result. This is just the preview. You have to click OK. And there we go. Right, make sure you click OK because obviously that preview does not accurately reflect what we see here. So based on what I've told you about scatter plots, right, the idea is to look at this and ask yourself, what does this tell me about my data? Look at the slant of the line and the incline and ask yourself whether or not that indicates a positive or negative relationship and what that means. Additionally, look at the sort of the shape that the dots take on. Notice that it's quite linear and these dots are generally pretty close to this best fit line. And again, ask yourself whether or not just eyeballing this data tells you about the strength of the consistency between Josh and Stacy. Again, it's a visual assessment, you're just eyeballing it, but you want to ask yourself, what does this graphic tell me about the consistency between Josh and Stacy? As I mentioned, you can copy and paste this graphic and put it into your answers, but you don't have to. As long as it's in your output, I'll be able to see it. So then, compute a Chromebox alpha for total depression. What is the score? You do this the same way that you did your internal reliability, which is to go to scale, reliability, remove the ones that you don't want. You could do your reliability analysis using Josh 123 and Stacy 123, as opposed to just Josh depress and Stacy depress. The reliability outcome that you get is going to be a little bit different, but generally the same. But basically, since we had such good internal reliability within Josh's scores and within Stacy's scores, it's okay to just have your interrater reliability be between their two averages. If you do a reliability using their individual questions, just make sure that you just use those. Okay, so you could do that. Looks pretty good. That's one option. But since the internal reliability with all of their answers were so high, you can say, screw it, I'm just going to do interrater between their two averages. And again, do not put this in the reliability. Do not. Makes no sense. Okay? Looks great. Basically the same, right? A little bit different because the variability of all of the individual items that Josh and Stacy answered were boiled down to a single score. So those two values can be a little bit different, but they're essentially the same because there was internal reliability and there's also interrater reliability present here as well. Okay. All right, so that does it for the actual analyses that you have to run. Again, make sure that any questions that have numerical answers, you actually pull this value out of your output and put into your answers. I basically need to know that you know what you're looking at when you run your analysis. Then lastly, most lab quizzes will have at least a couple more conceptual questions that will have you interpreting the results that you got. So one question is, do you think you can use the data from Josh and Stacy? Why or why not? So think about the analyses you ran, think about why reliability matters, and think about whether or not you feel comfortable using Josh and Stacy's values. Then there's a question on validity. So identify one type of validity that you believe might be relevant to the variables in the study. Describe why it might be relevant and discuss whether the variables do or do not meet the standards of the type of validity you identified. So critically for this question, do not conflate reliability with validity. Just because your answers were reliable doesn't make them valid. As I mentioned in the reliability and validity lecture, you can have a measurement that is reliable, but doesn't actually measure what you want it to, right? So think of a polygraph machine. It measures physiological arousal, and it's quite good at that. It's very reliable at measuring physiological arousal, but it's supposed to be measuring lying. Polygraph machines are not valid because they're not actually measuring what we want them to measure. They're not actually measuring lying, they're just measuring physiological arousal. So that's the distinction between reliability and validity. Just because Josh and Stacy's scores were reliable, the question is, are they actually tapping into the construct of depression, which is what you want? So ask yourself, how can you go beyond having reliable answers to ensuring that your measurement is actually measuring what you want it to measure? So go back and visit the list of validity types and think through how it applies. It can be as simple as talking through how face validity may be relevant, to content validity, right? Breadth of the construct being represented by the measurement. Identify a validity type and talk about how it is or is not demonstrated by the example I've described here. Do not say that the data is valid because it's reliable, because they're not the same thing. You need to evaluate them separately, okay? So that should hopefully give you enough to work on for the lab quiz. Does anyone have any questions at this time? How long should your answers be? They don't need to be long at all, just a few words. Okay. So my inclination is to, again, pause the recording here, give you guys a few more minutes to work on your answers and let me know any questions. And then after maybe 5 or 10 minutes, pick back up talking about proposal instructions. Does that sound fair? Oh, like the submission for the output? Okay, I'll make sure to get that published so that you can submit your work when you are done. Oh, that's because it's not due until Monday. I wanted to give people enough time to make sure that they work on any SPSS issues. So your lab quiz answers and output are actually not due until Monday. So I just published the week 2 module. And if you go to the assignments part, there'll be lab quiz 2 answers and lab quiz 2 output. So again, if you don't finish your lab quiz today, as long as you finish it by midnight on Monday, you're good. But I have published that now, so as soon as you're done, you can feel free to submit that. Right, so you want to submit your answers to the questions in that submission called Lab Quiz 2 Answers. Output is going to be in that submission just underneath that says Lab Quiz 2 Output. So basically, and I'll share my screen again to show you. Okay, so this here is my output. Again, this is a separate window and a separate file. Just save as Lab Quiz 2 Output. I would make sure to save it somewhere where you can actually find it. I've many a time had students who are like, I can't find my SPSS files, and I'm like, maybe you should make a file folder where you know they'll be, or on the desktop. Might take a minute to save, but then this will save as a file format called, I believe it's .sps, and you can just go ahead and submit that exactly as is. Got it? Okay, cool. Additionally, if you want, you can convert your output file to something else. Export. Yeah, you can change the file format for your output if you want to something else, like a PDF. But you don't have to. You can just submit it as the file type it wants to be, which is .sps, and you'd be good to go. From the App Store, I think it needs to be the Miami VPN. I think that's the only way you can bypass the license, because technically Miami's license is to use SPSS on campus, so that their specific VPN basically lets, I don't know, SPSS think that you're on campus. Again, I'm not an expert on what a VPN even is, but it basically lets you bypass the specific licensing issue that has to do with where you're located. If you are in Oxford and you're having trouble accessing SPSS, you can go. It says everything downloaded, but it's not letting me on the Josh Stacy depression file because of an error. I can email it to you, see if that works. Yeah, I'm actually going to stop recording because I feel like I'm a little all over the place.